Good morning all. Here's an AC Tech inverter drive. It is model M14150BK. Now the folks at the factory that this drive was removed from said they heard a big explosion from this drive. So let's pull the cover and we'll try to find the source of that explosion. Oh, look at that. There it is right there. That bus capacitor exploded. Oh man, that one let the smoke out. Okay. Let's take the drive apart up to a point where we can check the power devices, the IGBT and the three-phase bridge rectifier. To take this panel off, pull that out a little bit. There's notches that the panel rides in. Then it has a flexible ribbon connector right here that connects the panel to the control board. We got that out of the way. Next thing to do is to remove the control board. I want to take pictures of these connections right here so I can get it hooked back up before I put it back together later on after we do the repairs. Let me get some pictures here. That is amazing. That capacitor exploded like that. It happens. When they go, there ain't no doubt they go. Okay, I got pictures. Let's take this off right here. And the yellow wire goes to the bottom board. We'll have to undo that. Get another picture of that. Right there. Goes to, looks like terminal 14. Okay, there's that one right there. Take my hat off so I don't get in the way of the camera filming. Okay, we have the control board removed. Now, there's some good sized standoffs with spacers. Get on there. We don't want to lose those. Won't go back together very well without those. Now the two long screws go to the wall and the two short screws go through the firing board. Let's set this off to the side. Now we're going to remove the control board. You see these stake connectors? They go up into the control board. Now we're going to remove the firing board. There are two screws here, and then we have some plastic standoffs we'll have to free up. Take more pictures. Once we get this firing board out of the way, we'll be able to check the IGBT power module and the three-phase bridge. side undone. For this side. And last one. You have to squeeze these plastic clips of these standoffs right here. Okay. Let's set this off to the side. Now if we're lucky, and sometimes we are, if we're lucky, all we have to do is obtain a new bus capacitor. And right here is the three-phase bridge. Over here is L1, L2, and L3 into the three-phase bridge. And over here is T1, T2, and T3, the output, the UVW output of the IGBT. Alright, can you all see that? Okay, let's go and find, okay, black lead on the plus terminal right here of the three-phase bridge. Here's L1, L2, L3. Okay, let's do it from the terminal to make sure that we don't have an open trace of L1, L2, and L3 to the three-phase bridge. There's 0.447 from plus to L1, 0.450 volt diode drop from L2 to plus, 0.455 from L3 to plus. That's good. Now this is going to be the negative side, the ground side of the three-phase bridge. We're going to put our red lead on there and leave our black lead on plus. We're charging up the bus capacitors. We have from plus to ground 0.694 volt diode drop. That's good, so that's not shorted. Let's leave our red lead on ground, the minus terminal of the three-phase bridge, and we'll go to L1. We have 0.460 volt diode drop. That's good. L2 to ground of the three-phase bridge, 0.457 volt diode drop. And L3 to ground of the three-phase bridge, 0.457 volt diode drop. Three-phase bridge and our connections to the L1, L2, L3 terminal are good. Now we're going to check the IGBT. The UV and W terminals of the IGBT go to T1, T2, and T3 of this connector right here. So I'm going to put my black lead back on the plus terminal of the three-phase bridge. Here's T1, 0.384 volt diode drop. That's good. T2, 0.383 volt diode drop. That's good. T3 to plus, 0.383 volt diode drop. That's good. Now we'll swap leads. I'll put the red lead on the minus terminal of the three-phase bridge, and we'll go T1, T2, and T3 again. Black lead this time on T1, T2, and T3. On T1 we have 0.383 volt diode drop. Good. T2 with the black lead, 0.383 volt diode drop. That's good. T3 to ground, 0.383 volt diode drop. So far, looks like the only thing that went bad was that bus capacitor exploding. That happens. They give up the ghost. Alright. Okay. Well, we'll order a new bus capacitor. Later on we'll throw it in there and put it all back together and see how she does. Hopefully we can bring this one back from the dead too. We'll see. We'll see. Shoo-wee. That was an easy one to troubleshoot right there, wasn't it? You could see what was wrong with it. Okay, folks. When we get the new part in, we'll give her a go. Thank you very much for coming over and seeing what we're working on next. Maybe we'll succeed, maybe we'll fail. That's part of living. Enjoy the rest of your day. We'll see you next time. Can't get all the solder out of the vias, so I'm going to rock the capacitor off the board. I heat up one side, and then I'll rock the capacitor. I'll pull the capacitor the other way. Keep going back and forth until the capacitor falls out. .820 microfarad at 400 volts. I'm going to remove this one also. It looks like it got scorched from this capacitor beside it exploding. So I don't want to take no chances with that one right there going up in the future. So we'll pull that one off the board. This side gave way. There we go. Remove the solder from the vias. I'm adding new solder to the old solder to help the old solder flow. There we go. Got the two caps removed from the board. All we have to do now is wait for the new parts to come in. Put the new caps on the board. We'll fire this thing up and see how she works. All right. We'll come back then. Evening all. I took Saturday and Sunday off. Saturday, my son, who's back from the Army for good, he took me out to eat. And I had me some catfish, and he had steak. And then today, Sunday, my daughter ordered up a bunch of Domino's pizzas, and we went over to her house and spent some time with both my children and grandchildren. What a wonderful weekend I had. Well, let's get on with it. Here we are, back to work. We got to do the paperwork here. We got an AC Tech inverter drive, model M14150BK, and this thing This thing hauls. This is a spindle drive. It runs a spindle motor. To make this drive get up and go, we got to have these connections right here as a minimum. There's more to it, and I'll show you the rest of the connections down here in some pictures at the end of the video. But first, we have this common terminal, terminal 2, and here labeled 2 also. We have to put a run-stop switch from terminal 1 to terminal 2. When it's open, the drive is stopped. When this switch is closed, the drive runs. Now for the speed reference, we have to have a potentiometer right here. And I had a 10K multi-term potentiometer at this point right here. One wing connected to common on pin 2, the same pin 2 as the run stop switch, and the other wing of the potentiometer on pin 6, which is 10 volts DC output. So we've got 10 volts here and 0 volts here. The voltage reference in to increase or decrease the speed of that motor, the wiper connects to 5A. So when I have the wiper set all the way down here, that motor is going to run at the min speed. The min speed could be anything. It's programmable. But in our case, the min speed was 0. So when the potentiometer wiper was at 0 potentiometer, oh yeah, when the wiper was at 0 potential of pin 2 common, that motor did not run. The output that we saw in the video was not running. So when we increased the potentiometer to a max of 10 volts DC, that output to the motor is going to be running at full RPM. Now down here, this is odd. I had to, in order for this drive to run, I had to jump 12A, which is auto mode select, to common. Without this jumper wire right here from 12A to 2, regardless of whether I close that run stop switch and increase the potentiometer to a voltage reference input, that motor still did not run. I had to jump this out right here in order to get that motor output to turn on. Isn't that odd? Now over here, I didn't have a motor connected. I didn't have a spindle motor to connect to T1, T2, and T3, but I was able to look at T1, T2, and T3 with the Fluke oscilloscope. Down here, the line input L1, L2, and L3, the data plate on the drive says 400 volts AC to 480 volts AC, 3-phase. I applied 380 volts AC 3-phase from the shop's power transformer, and the drive came up good. There you go. That's how you connect your AC Tech inverter drive and power it up and enable it to run. Easy drive to hook up and run. Very easy. I like that drive. That's a good drive. Alright, thank you very much for coming over to see what we're working on next. I always enjoy it when we both learn. We both learn something new every day, don't we? Thank you very much. Have a good day with your family, and we'll see you tomorrow.